Now we're going to learn a type of differentiation. So differentiation is a process of taking a derivative. And we want to learn how to take the derivative of something that's implicit. So this is implicit differentiation. So up until this point, we've looked at functions where y equals f of x, where y is expressed explicitly in terms of x. That means we have y on one side by itself. That's an explicit function. We've always expressed y explicitly in terms of x. But this whole next section says, what if we don't just solve for y by itself? Let's be able to take the derivative of that too. So we're going to express y implicitly in terms of x, which just basically means we'll have x's and y's mixed together, and it'll be to the point where we really don't even want to solve for y because it doesn't make taking the derivative easier to do that. So for instance, if you have something like y squared equals x minus 3, this is called implicit. And that's because I don't have just y by itself on one side. I have y squared. Here's a pretty simple implicit equation. To get this to be explicit would require us to take the square root of both sides. So we'd have to do plus or minus the square root of x minus 3. And did I really make the derivative easier? No, I've made it harder because I have this plus or minus out front. I really have two equations. Y is equal to the positive square root of x minus 3, and y is also equal to negative the square root of x minus 3. So making this an explicit equation means I have two derivatives that I have to take. So instead of solving for y, because most of the time we just flat out don't want to take the time to do that, we're just going to take the derivative of something implicit. And we want to do that because we want to get a single unified derivative. We're going to get the derivative by itself. So we're going to solve for the derivative, which means we're going to solve for dy dx. This will be the first time we use that notation where we say dy dx instead of y prime. If you've done implicit differentiation before and you used y primes instead of dy dx, we're going to kind of get rid of that in our minds right now because I've had a lot more success just writing out dy dx and writing the derivative as a y prime. So the first step for implicit differentiation is simply going to be to differentiate. Take the derivative of both sides. So another word for taking the derivative is differentiate. We're going to differentiate both sides. And the difference now is that we care that it's with respect to x. We've always been taking the derivative with respect to x, but before we didn't have to think about it too much. So with respect to x, what that really means, if we're going to differentiate both sides with respect to x, that means we're going to write a dy dx next to each derivative of y. Not just each y, it's to each derivative of y. So just a little bit extra work. Take the derivative as usual, but the derivative of y squared isn't just 2y, it's 2y dy dx. Because I took the derivative of y, I need to put a dy dx next to it. The second step is to get that derivative by itself. So we're going to solve for the derivative, dy dx. We want to remember how to solve from algebra. That means we're going to distribute first, combine like terms, and then divide to get the variable by itself. So just some review for solving. So if we do that here, we want to find the derivative. Find dy dx means find the derivative, given that the original implicit equation is y cubed equals x. So my derivative of y cubed is going to be 3y squared. Bring down your power, subtract 1 for your new power. But now this gets a dy dx next to it. And that's because we took the derivative of a y term with respect to x. So we need to put a dy dx there. Equals the derivative of 1x is just 1. And this whole time I could have been writing a dx because we took the derivative of x with respect to x. But I would really never write that because dx over dx is just the same thing as 1. So So we really don't need to write that in ever. So what do I need to do to get dy dx by itself? I need to divide by that 3y squared. So I'm going to divide both sides by 3y squared. So dy dx is going to equal 1 over 3y squared. Now I want you to try the second example, keeping this all in mind. Take the derivative as usual and just put a dy dx next to that y term. And I'll post that solution.